So now we come to the third paragraph, that is timestamp server. It's a small paragraph. It reads, the solution we propose begins with a timestamp server. Now, this basically emphasizes that the complete ecosystem of Bitcoin, the complete ecosystem of hashes, the complete ecosystem of connecting blocks, the complete chain of blocks is enabled primarily on a timestamp server. A timestamp server works by taking a hash of a block of items to be timestamped and widely publishing the hash, such as in a newspaper or a usernet post. So the timestamp server is enabled in the all transactions, any event that happens, any kind of transaction that happens, any kind of bitcoins or tokens which are sent or received, they are all enabled on timestamps. And these timestamps are basically epoch times. So it is not that in case I do a transaction today, timestamp will be indexed as 22nd April 22. No, it will be in epoch equivalent. Now what epoch equivalent is, I have already a video on this. Basically, I think I had covered in the target or difficulty thing. So you can have an overall view of what epoch time is or how does it work. So that kind of timestamp is enabled on each event. So in the previous paragraph, when I had spoken on transactions, so when I had mentioned that the digital signatures, they provide a way to mathematically prove to the sender or receiver that he has sent this or he has received this. So all those transactions that what we are talking about is all these transactions have a timestamp enabled on these, and this is what it is mentioned here, and it is basically giving out comparing the same with a newspaper or a usernet post, which I am unable to understand why newspaper or usernet post. It is a simple thing that there is a timestamp which is enabled on all events, all transactions, and all these transactions have unique hashes, and all these unique hashes are indexed inside a block, and all these hashes give out a root hash which is indexed per block, and this root hash is indexed in the subsequent block. Then further it reads, the timestamp proves that the data must have existed at the time, obviously, in order to get into the hash. So while each and every event is enabled with a timestamp, so whenever I see a transaction, whenever you explore any transaction which has happened in past 1 year, 2 years, 3 years, 4 years, a decade back, whatever transaction you see, you will see that a timestamp is enabled on that, and that timestamp is basically defining that it is verifying that that particular event had taken place on so and so date, on so and so time, and on so and so minutes, hours, and seconds, that way. So each timestamp includes the previous timestamp in its hash, forming a chain with each additional timestamp reinforcing the ones before it. So we come back to the same thing, that the blocks are connected to each other mathematically, and not only mathematically they are connected, but they are all enabled on connected timestamps. So once a timestamp is indexed in any particular block, and once that block has been indexed in the blockchain, thereafter it would take an impossible kind of effort to basically change it. So with this, we come to the end of this third paragraph, basically a very small one. And in the small schematic that we see here, it is basically two blocks. There are two blocks, and each block is holding some kind of an item, and these items are transactions, and each block has got a unique hash, and this hash is being transferred, is being indexed in the subsequent hash. So when we see the left block, it has a unique hash, and this hash is subsequently being indexed in the next block. So the hashes are connecting each other. So with this, we come to the end of paragraph 3, and next we meet with paragraph 4. That's one of the most important paragraphs. That's proof of work. Thank you.